Okay, so let's look at this one, 2013 paper 1 question 5. Same thing. This tells you that this is 3 repeating units. So for those of you who join us later just now, we missed out the first part. This is repeats every 3A units. Okay, the rationale is very simple. So if you put f x plus 3A equals to fx. Okay, so if you were to put this as, let's say this, if this is x is equals to a, fa, right? Then this will be a as well. So this is fa. A here will be 4a. Okay. Now then this is not it. You can also move this to this side here. So now if x becomes 4a, this will be f equals to 7a. So you can just keep wash, rinse, and repeat. Here then, this is 7a. Okay. So if you move this over to the other side, if x becomes 7a, same thing, this will be f equals to 10a, and so on. So you realize that you can actually just add 3a here. Add 3a. Okay, don't forget, like if there's a forward, there's also a backward. So this is also minus a, minus 3a, minus 3a, minus 3a. So this means that if you do this, this is actually f equals to minus 2a. Okay, so it just goes on forever lah. You can just keep adding 3a. It repeats every 3a time. Just remember that. Okay, once you've done that, really now we are told to sketch a graph. So I'm gonna draw to scale. So I'm gonna bring out a grid. Okay, there you go. Okay, now the first thing is, of course, from minus a to a is this function here, then a to 2a. So a repeating unit is from a domain of minus a to 2a. Okay, because if you combine these two, minus a to 2a here. So I'm gonna just sketch it out, because minus 4a to 6a. So this is 1, 2, 3, 4 around here. And then what is this line? This is, it's 0. Okay. It looks like that. Y equals to 0 here. Okay, great. So this is fx. This is x. Okay, there you go. Minus 4a to 6a. Okay, great. I'm going to draw from minus a here to a. Okay, what is this equation? The first one. So you just let y equals to 1 minus x squared over 2a. Is y squared equals to 1 minus x squared over a squared. Y squared plus x squared over a squared equals to 1. Okay. Now, when you see this kind, I always tell you that for conics, when the coefficients x squared and y squared are the same, it's a circle. If it's of the same sign but different value, then it's an ellipse. And if it's different sign, so means y squared minus x squared over a squared, then it's a hyperbola. So this one is clearly an ellipse, right? This is an ellipse. So this is an ellipse. Remember, this one here is the vertical stretch. So if this is, the center is 0, 0. Okay, very, very simple. The center here of the ellipse is actually 0, 0. Then this is a units to the left and right. Okay. Then here this is 1 square. So the vertical stretch here is 1 unit. So we could just draw this out as an ellipse. But take note, this is only taking the positive part, guys. It's only taking the positive part. Just the positive part. There's no plus minus in front. There's just the positive part. This has to be a function. So it only takes the positive part. Okay? It only takes the positive because y positive. Square root, the value there is positive. So this case here, is a, they never tell you a is bigger than 1 or not. So it's the ellipse here. So I'm probably just going to draw it like that. So remember, I'm going to put my 1 here. That this is So move on to 0. Y equals 0 is quite okay, right? Y equals 0 is just a horizontal line there. So horizontal line A to A. Am I right? A to 2A, yeah. So it's here. So this one, please use another color. Maybe my axis should use another color then. Axis use. Okay. Okay. Like that. There you go. So if you want minus 4A to 6A, this is one repeating unit here. Okay. What you need is then just replicate it. So the good thing about having this is I can just control paste. It's really just control paste 3 units, okay? A to 6A, so means I just keep repeating, okay? So 2, 3, 4, 3, 4, 5, and 6. Okay, so here would then be okay, we need to stop at 6A, so we need to cut off certain part of the graph, I think. So this is 3A. This is 3A, 1. This is 4A. This is 5A, and this is 6A. And 6A, 1. Erase it down. All these questions here, please try them again. They are pretty good questions there. Okay, so there you go. 6A1. Yay. Great. Then what we're gonna do next is 4A. So we're just gonna repeat the behind here also. Just copy paste. This is one repeating unit here. So the next one will be a line here. So I'm gonna just put a line here, 1. Literally just copy paste, guys. I'm doing what I did just now, which is copy paste. Okay, yeah. Okay. Minus 2A. Minus 3A minus 4. Minus 3 is here. Minus 4. There you go. Just label the endpoints. Usually is better. So this is y equals to. So as you can see, the repeating unit can be can be about off center here. So sometimes most of the question would actually be from 0 to some value. Okay, but this case here is from minus 2A to 2A. So just make sure you understand this concept that if it can be like in the negative region as well for the repeating unit. So this part here, if you want half A to root 3 over 2, root 3 over 2 is 0.866A. 0.866A roughly. So half A is here. Here's half A. Root 3 over 2A is here. Okay. So is between these two lines here. This is the area that you're looking at. Okay. So half A to root 3 over 2A. So in terms of A and pi, use a substitution. So I'm just gonna do it. But to half a to root 3 over 2a. And after which we're going to just use fx dx. Okay. Fx is root 1 minus x squared over a squared. This is just half a 1 minus x squared dx. Now you of course use this equation, right? This equation here, because you look at the graph is half to root 3 over 2a is this region. So you're actually using this equation, not this 0. So you can just start integrating using this equation there. It's 5 marks. So let's see how we can just do it. You're given the substitution. X equals to a sine theta. Okay, x equals to a sine theta. Okay, so dx d theta will just be a cosine theta. So we know that dx equals to a cosine theta d theta. Just know that. Then what we're going to do is actually just substitute it in. Now this one, careful. When you substitute in, make sure you change the boundary there. But you don't want to change also can. Later on you change back. So this is 1 minus a sine theta square over a square. Dx is a sine dx is a cosine theta d theta. Okay, some schools don't allow you to write this. Like I said before, you will see this in university textbooks one. So A level, I don't think they care. So really just anyway, you're sitting for A level next, right? So nobody cares. It's okay to write one. Here would then be make sure you know that this is half a. So when theta, change the boundary lah. I would suggest changing the boundary, because at this juncture here, you should just follow a set of fixed rule here. This is easier for you. Sine theta. So sine theta, this will give us sine theta equals to half. So this theta here, sine theta half is actually 30 degrees, right? So sine inverse half, this will be 30 degrees, which is actually just pi over 6. 30 degrees pi over 6. So this is pi over 6. Same thing, change the boundary on top. There's root 3 over 2a. When x is root 3 over 2a, sine theta, then this will just be sine theta equals to root 3 over 2. Then theta will just be pi over 3. Okay, 60 degrees. There you go. So that's 60. Just make sure everything is done correctly lah. So from here, this is pi over 6. This is pi over 3. 1 minus sine square theta. I bring it out. You can only bring out the constant. Please know that. A is a constant. You can bring it up. Then this will be cosine pi over 6. Pi over 3. This will be cosine. So cosine square root. Then this will be cos square theta. Okay, remember, when you do this integration, this is secondary school stuff already. It's not any H2 math stuff. When cosine theta square, reduce its degree to 1. So because you can't integrate cosine square, you can only integrate 8 of the integration expression, which is tangent sine. Whatever you learn in secondary school, you can actually integrate sine, cosine, secant square, and cosecant square. Then the 4 other ones which are from MF26. So remember this 8 lah. this MF26 and then this any of this 8. So of course, you can actually reduce this to a single degree here. So this cosine square is actually just cosine 2a equals to, use this double angle is found in MF26. Okay, so this will be cosine square a is equals to cosine 2a plus 1 over 2. Okay, so this case here, when you're doing this will just be a over 2 . Okay, there you go. So cosine 2 theta would just be a over 2, integrate it with sine 2 theta over 2 plus 1. That will be pi over 3, pi over 6. Key in calculator. Okay. My goodness, this is theta. Okay, then this sine 2 theta to the pi over 2 plus pi over 3 minus of sine pi over 3 over 2 plus pi over 6. Okay, so quick tip here. I don't want to go through. Okay, if you do not know how to do this, the fastest way is just use a calculator. So this is the second quadrant. 2/3 pi is actually second quadrant of sine. It's actually positive, but if you do not know what to do, this is what you do. Just use calculator. Okay, this is sine 2/3 pi times 180. Pi is 180. This is actually root 3 over 2. So you square it. We cube it for what? Okay, square it. This is root 3 over 2. Okay, because you square your answer, you get 3 over 4. So means this value is the root of it. So it's root 3 over 2. So this is root 3 over 4. Sine 60 will be root 3 over 2 as well. Okay. So it happens to cancel off each other. So pi 1/3 minus 1/6 will be 1/6. So this will just be no need to put units too, because square units you can put it's not wrong, but because they never say area, so I'm gonna just find the value.